Technical Bulletin TB208. On the screen is the 2015 version. The changes, as highlighted on the screen, are we have removed the first paragraph as it is duplicated in the commentary and recommendations below. The commentary and recommendations TB208 4.1 has been reworded, and it is shown that there is a separate paragraph as it is an entirely separate point to the first instance. It's a grammatical change. There is no other changes technically with regards to this commentary and recommendation. TB210, 15 and 18. Again, a clarification. The contacts of either switch will start the pump or normally closed contacts. This has been changed to normally closed contacts of either switch when the pressure falls. We have just reworded this for a clarification. There is still no change technically to TB210 in the latest version. Technical Bulletin TB216. Again, this has changed. The first paragraph hasn't changed. What we've done is clarified the RC19 recommendation for non-sprinkler protected buildings, whereby it asks for a 6-metre aisle around any protective cages. This relates to sprinklers to buildings with not fitted with sprinklers, and it's just been put there to avoid confusion. RC19 as a document is listed in the supplementary information in Part 3 of the LPC rules. So if anybody hasn't read that, that is within your standards. TB217, again we have an issue with regards just to a mistake, where we have the less than or equal to 40% volume in the original 2015 version, and it also just mentions rubber content. We have reworded and corrected the symbol. It is expanded rubber greater than or equal to 40% by volume. Again, no other technical change other than a mistake that's been corrected. Technical Bulletin TB232, the 2015 version. Again, we've just, there was a double negative in there. We have removed the word not. Therefore, all installation control valve sets designed to comply with Annex F must have bypass or duplicate. That's all the correction is on TB232. Technical Bulletin TB232. Again, we've reworded the commentary and recommendation to reflect what was in the previous 2014 version of Annex H, which requires monitoring as standard. Any sprinkler installation designed to Annex F requires all valves to be monitored. If it's not required to be to Annex F, it is not a requirement to monitor every single valve. The requirement is, as it's put in the second paragraph of the commentary and recommendation, that it's to be sought confirmation with insurers, so that they will decide on the security issues and other issues surrounding the site whether monitoring will be required of every single valve or just partially monitored. TB233, I'm sorry that we're rushing through these so quickly, but unfortunately there isn't much to discuss on the minor modifications. Again, we've just removed the life safety requirement, as life safety has been removed from the standard from 2015 to avoid confusion between two systems. We have also, in BSEN 12845, modified the tabbing issues. So the alignments and the tabbing with regards to moving from the BSEN to the TB has been updated and all errors corrected as far as we know so far. That's what we've done up to now on the minor modifications. I'm now going to pass you over to my colleague Martin Hartley. He was going to go through the significant changes as listed on the screen.
Good morning, everybody. So these are the topics that I'll be discussing: TB203, TB229, TB234 and TB237. So we'll go into those in a bit more detail as we go through. The first change I'm going to discuss, although these are significant changes, is a relatively minor one actually. The title of section TB203.3 just previously missed the title of service and maintenance schedule, so we've just put that back in now that you can see there. The more sort of impact changes are that quarterly routines covered under TB203.3.2 that listed the requirement to test flow alarms quarterly under also in clause 20.3.2.8 and 12845. Systems installed for property protection purposes, we allowed the testing of those alarms to be annually rather than quarterly from a cost perspective point of view. But where you've got flow alarms in life safety projects, or rather systems complying with Annex F, we didn't feel that we could reduce those to just being tested annually, as most of the flow switch manufacturers have a recommendation to do those quarterly. So the life safety projects, you'd still test the flow alarms quarterly, but the property protection systems, you can push that out to annually now. And here's the changes as reflected now in the printed latest version. With regards to testing dry, alternate and pre-action systems, TB203.3 2000 was not specific enough to ensure.
You know what I mean?
Sorry, we have some corruption here on the speaker. Apologies for that. So TB203.3.32 clause was not specific enough, we didn't feel, in terms of ensuring that the dry, alternate, pre-action systems are periodically tripped to verify their performance. So in fact, what the clause generally was restricted to say was that alarm valves, the moving parts of dry alarm valves, pre-action valves, and any accelerators and exhausters shall be exercised in accordance with the supplier's instructions. We felt that was perhaps not testing enough for certain systems, and TB208 only deals with commissioning tests for these systems, so not ongoing periodic testing, which we felt was important. So we've split this now into two more robust tests. The first test is an annual test, and there's a new clause, TB203.3.412, which was added to the Technical Bulletin, and this allows then for functional testing procedures to be carried out annually, exercising the moving parts annually on both dry, alternate, and also pre-action control valves and accelerators, etc. And this also allows for alarms to be tested, but it doesn't necessarily mean every year that you have to flood the system and do an actual sort of simulated fire test to trip the valve. And we felt that annually that could be a little unnecessary, given that by flooding the system you've got a problem then in draining the system off and recommissioning it. And other standards consider this to be not an annual requirement, but perhaps every 3 years. So we've now changed that to every 3 years. The commentary and recommendation.
What the white ones? What are they called? Yeah.
Sorry, we've got some corruption on the feedback again. The commentary and recommendation requires that functional testing to be undertaken for existing alternate installations can be carried out at the changeover period. So you can actually do a functional test, a full sort of fire test with an alternate system when you convert in the spring from dry to wet, and you can physically trip the valve. But for dry and pre-action systems, that's not really the case. So we've got the commentary and recommendation there that confirms what I've just said. So yes, for dry and alternate and pre-action systems, the full trip test that we're now saying is required is every 3 years. So that's intended to be now a full trip test, so discharging the air at the remote end of the system to physically trip the valve, test the accelerators, etc., fully operate the drying on alternate and pre-action systems and any accelerators and exhausters. So you do a full fire test basically, and that allows you to test both the valves are operating and the alarms and the fire signals are also transmitting correctly. So that's a full fire test basically, as opposed to just exercising the components of the valve. Moving on to TB229 variations now. We've introduced, which I'll come on to later, we've introduced a new flushing technical bulletin, TB237. So we've needed to modify TB229 3.15 simply to include the reference now to TB237. We've also taken the opportunity, though, at this stage to include a requirement for air venting of gridded and loop systems. It's included in the this flushing TB amendment because the only reference to air venting in BSEN 12845 is in the clause, I think it's 15.6, regarding flushing. So we've kept the air venting in that same clause. There is a slight duplication on the TB229. You'll see that the clause relating to air venting has been introduced into an additional clause in TB229, which it shouldn't have been. That was a publishing error, so that will be cleaned up, and you'll get a revised copy of that shortly. So just going back to the air venting situation. This is particularly important for gridded systems. We're looking at a typical sectional view through a range pipe on, say, a warehouse where it goes up and over the roof, and that's the position at the apex. So all those range pipes on a gridded system will undoubtedly have air in the top section of them. For the range pipes where the fire operates the sprinkler head, then the air is undoubtedly going to be vented out of those range pipes through the open sprinkler heads. But as you will probably know, with the hydraulic calculations for gridded systems, all ranges on a gridded system are flowing water, and there's very often very little pressure difference between the front track and the back track start and end of those range pipes. So that pressure difference is unlikely to move that air out of the top section of those range pipes, and therefore those range pipes won't flow any water, which the hydraulic calculation allows them to do, or takes into account. So that's an error, obviously, in what's perceived to be the hydraulic analysis of that system performance to what's actually going to be happening when you've got air in it. So we've now introduced a venting criteria, which is now covered in that TB229 3.15. So it requires that all new gridded design systems need to be vented. It requires permanent and accessible facilities to enable you to do that. In the sense that you need a manual vent valve to be able to bleed that air off the top end of the system. Typically on a warehouse, you could link all the tops of your ranges together, route that through to a manual air vent valve, and then you could relieve all the air at either original commissioning stage or when the system is filled. If it's been drained for any particular reason, when it's filled again, then you can vent it and ensure that you've got rid of all the air. We've asked for suitable signage to be displayed by those manual release valves so that people can understand exactly what they're for and when they need to be used. Once you've expelled the trapped air from sections of installation pipe work, you lose that sort of shock absorber benefit of having air in your system. Obviously, water won't compress. So if you've got ambient temperatures in changes, for example, that could increase the pressure quite significantly in the system when you've expelled all the air from the system. So there could be a risk of damage. So what we're saying really is that you need a pressure relief valve, and that only needs to be a relatively small pressure relief valve, a 1/2-inch pressure relief valve, 15 millimetre, at the insulation control valve sets, which will keep the pressure in the system to a required level if the ambient temperature pushes that pressure up because you've got no air in the system. So there's a requirement for the pressure relief valve there. So we've got a further amendment now in TB229, which is clause 3.17, dealing with Annex H, which Dale touched on earlier. And this is, again, just to sort of reinforce the fact that although Annex H requires monitoring under 12845, BSEN 12845, if the system is installed for property protection purposes, then the insurers recognise that there's a significant cost of electrically monitoring all the valves, and if you've got other systems such as particular site security or management controls, which mean that there's reliability on the efficacy of the system without having electrical monitoring of the valves, then they're not going to require electrical monitoring as a universal requirement on every system. So you've got an option there of talking to the insurers and getting an understanding from them as to whether they want those valves monitored. Further change is just a clarification really on the curve for the beam rule under 12845. The curve number 5 was poorly produced, and obviously the BS just reproduced the EN standard as far as 12845 is concerned, so it was just poorly produced. So we've literally produced the curve under TB229.3.18 just to show you the shape of curve 5 and the impact on that beam rule requirement. Another little correction really, I suppose. Under TB229.3.19, the BSEN table 30 regarding the range pipe diameters kind of caused some confusion just because of an alignment problem. So you can see there that the last range on the left-hand column was in the wrong position. It should have been aligned with all other layouts. So we've simply corrected that in TB229.3.19. As further sort of addition now that we've included in TB229, the current requirements and under 12845, you have to, if you're doing a pre-calculated system, you have to do your calculations between your design point and your valve set based on 1,000 litres a minute, and under the hydraulics clauses in the standard, you can produce those pressure losses per metre quite easily. But in the older standards of the rules, BS 5306 for instance, we had a table that already gave you those losses per metre. We're just reproducing that table now because it's just easier for designers to have that table produced. You'll see that anybody who's used to using that old table from 5306, that the pressure loss per metres stay the same, even though we're now talking about slightly different pipes. We're now talking about 10255 pipes as opposed to BS 1387, but the friction losses are essentially the same, but for sort of 1 or 2 decimal places difference. So yeah, we've reproduced that table now in TB229 for ease of designers calculating pre-calculated systems. And another sort of relatively minor change in TB229.3.21. The table from 12845, table 22, didn't include any HDPE type plastic, so we've now added that for underground plastic mains, for example. We've listed that as a C factor of 140. You have got some manufacturers who might give you a C factor of 150, for instance, for some of the high density pipe work, but we thought 140 was a reasonably conservative universal C value to use. So that's just been reproduced there now in that amended table. TB234, protection of high hazard storage configurations. We had various feedback from when that was first published regarding the interpretation, or you could say the misinterpretation, of the increase in the design density requirement where you had excessive roof clearance. There was misunderstanding about where the 4-metre clearance was derived from, whether that was from the top of the actual goods being stored. So we've tried to do an amendment that will clarify that for people, and we've actually included worked examples, so hopefully that will make it clear now. But if I just run through what those changes are, hopefully that will make more sense to people. So the existing words in the CNR required the use of the increase in design density option to be declared as a minor non-compliance. This is because it's not an actual requirement, it's a CNR, it's a commentary and recommendation, so it was could be treated as a minor non-compliance on any certificate of conformity issued. Because there's three options that you could also use. You could put a false ceiling over the top of your storage wrist to stay within the 4 metres and protect it that way. You could put ESFR systems in. There's a number of options. This increased density is just another option, really. So you can declare it as a minor non-compliance on the certificate of conformity issued. But of course that may not be the case. You may not have a certificate of conformity on every project. So basically we've now included in the standard for a clause that will say if you issue any completion documentation, list it as a minor non-compliance on there. I'm just running through the CNR now and showing you the before and after changes. So the left-hand part of the screen is listing the 2015 version of that CNR, and the right-hand side is now listing the 2018 version. So what we're trying to do to try and clarify the interpretation of this is to use some different terminology. So we're now talking about the height of the storage as you consider it in this ceiling clearance as being the permissible storage height, and we're referring you really to the table. It's actually the T2 table, which covers the category of products stored, the design density, and relative to the actual storage involved. I'll come on to another slide which perhaps explains that better as we go through. And again, we've just changed the diagrams to list the permissible height rather than the maximum height. There was some confusion about what was meant by the maximum height, and some people were taking that as the actual maximum that you could go to under table T2, which could have involved 30 millimetres a minute, which wasn't actually the intended purpose. So we're now calling the permissible height as being the height that you take into account. And the permissible height you'll see under the legend for the right-hand diagram there, with permissible height of storage above the uppermost level of intermediate level sprinkler deflectors for the given storage configuration, category of products and design density relative to the tables in this technical bulletin. So if we kind of move on to the tables eventually, I'll show you what that means. So the permissible storage height is the storage height as specified in the tables in the technical bulletin relative to the actual storage height, category of goods and storage configuration. So for example, if you've got an actual storage height of, let's say, ST1 floor mounted block storage, that's actually at 3.6 metres, and let's say it's category 3 type storage. If you go to the table TB234.T2 and you looked for what was the applicable density for a 3.6 metre high ST1 category 3 storage, you'll see that the table gives the maximum permissible height as 4.1. So you're covered then with your density of 4.1, or required for the 4.1 height of storage, and that's the permissible height then. The 4.1 metres is the permissible height. You then take your 4 metres above that, so your ceiling protection shouldn't be ideally any more than 8.1, and if it is more than 8.1, that's the dimension that you take into account when you're doing your adjustment in your roof density. So if we just continue on, I'll show you the table in a second just to illustrate that in a little bit more detail. But so again, continuing on from the commentary and recommendation, left-hand side there, showing you what's in TB215 at the moment. 2008 version now shown on the right-hand side. There's no change in that particular section of the commentary and recommendation, but the continuation from there, you can see here's where there are some changes. So the first change I'm showing there is the documentation for using this increased density. So you should either record that on your certificate of conformity, or in the case of systems where certificates of conformity are not issued, then record it on the formal completion documentation, because it's not an actual requirement, it's a commentary and recommendation. It's one of 3 or 4 options you've got. And then following that, in this box at the bottom of the table on the right-hand side, or the CNR on the right-hand side, is where I've tried to use an example to illustrate how you apply the increased density criteria. So for ceiling clearances greater than 4 metres and up to a maximum building height of 18 metres, and where one of the other 3 mitigating measures listed in TB234 4.2 is not adopted, that's your false ceiling or your ESFR option, etc., then determining the adjusted design density at the ceiling level sprinkler system is as follows. So use the specific design density for the relevant storage height configuration of products listed in tables TB234.2 if it's ST1 storage. The other tables are for the other type of storage, and it's the same principle for no more than 4 metre clearance height. So for clearances of more than 4 metres but not more than 5 metres, then add 2.5 millimetres per minute for that 1 metre exceeding the 4 metres. And then when you get over your 4 metres, then you're adding a millimetre per minute density for every metre or part metre going over that 4 metres. So I'll come on to the tables in a second and just show you sort of in a little bit more detail what I'm trying to describe there. So the other point we're making here is that if you're using this increased density to cover for the excess clearance, there's no requirement to increase the area of operation in addition to that. So if, for instance, your increased density pushed you to a density in table, let's say table T2 for ST1 storage, if your increase in density for this ceiling clearance pushed you up to a density that normally increased the fire area from, say, 260 to 300 square metres, there's no requirement to increase that fire area as well. You would just increase the density over your original fire area, your original AMAO. So, if I, just one final look at the end of the CNR is just the same wording. So, if I now just pull up one of the tables just to show you what I mean. So, let's say, taking my previous example, we've got some ST1 storage. We've got actual sort of storage height of 3.6 metres, say, and it's category 3 products. So, you can see from table T2 there that you exceed the 3.5 metres that's listed for 10 millimetres, so you'll be looking at 12.5 millimetres over 260 if your product is 3.6 metres high. So the permissible storage height you've got there would then start at 4.1. That's the permissible storage height. And it's the 4.1 that you would then use to establish whether the ceiling clearance is within the 4 metres or not. So you could go up to 8.1 metres then, using 12.5 millimetres a minute over 260 square metres, and you wouldn't have to increase that if your ceiling height was at 8.1. As soon as you go over the 8.1, the first metre or part metre over your 8.1, you'd increase that 12.5 by 2.5 millimetres per minute, so that would go to 15 if it was within 1 metre more than the 8.1. Any further metre clearance over that, you'd add another 1 millimetre, and that would determine what your density would be. But you can see there, if you got to a density that was well, either 20 millimetres a minute or above, you can see that the table's showing you a fire area of 300 square metres there. That's not required just for this density increase due to the ceiling clearance. You'd stick with your 260 square metres. So hopefully that's a little clearer. We've also got a minor change actually on TB234 5.6 on slotted and solid and slatted shelves, whereby there was just an error in the reference clause that was used. It used to say, as you can see, TB234.5.2. It should have been TB234.5.3. So we just corrected that. Then we move on to the flushing document, which is the new technical guidance document now on flushing underground mains. Obviously, if underground mains are installed in non-sort of clean laboratory situations, they're in the bottom of trenches, it's quite possible to get debris and contamination into the pipe when you're installing underground mains. And when we say underground sprinkler mains, that can be any main related to the sprinkler system. So it could be the tank infill main, it could be the pump delivery main between the pump house and the building. So any underground mains basically are captured by this TB. So the consideration really is, as it says there, when underground mains are installed, modified or repaired, a variety of foreign materials such as rocks, stones, nuts, bolts, sticks, sludge, anything can enter the pipe. These can cause obstructions either in the underground main, in the valve systems, or if the system operates, it can actually be flushed through the sprinkler installation and can block the actual sprinkler orifices. And these blockages can severely restrict the flow and the performance of the sprinkler system to perform its tasks. So we're saying that for newly installed or modified and repaired underground mains, they need to be hydraulically flushed to remove any of this foreign material before connecting the underground main to the sprinkler installation. So if you're starting an installation from scratch, you're doing it, a new installation, carry out this flushing test before you even connect it to the installation above ground. Try and do that at that stage so there's no possibility of flushing any debris into the system. Appreciate that doesn't always happen. You may have existing systems that you need to flush, so we deal with that under TB237. So we've just listed a few precautions to consider prior to carrying out that flushing. So, for instance, there are overriding procedures under Annex J to consider, but more particularly, installation control valve sets, the main isolating valves, together with any valve bypass valves, they should all be closed securely to make sure you don't get any flushing water into your system at that stage. Ensure that there's adequate local drainage facilities to take the volume of water that you'll be discharging during this flushing exercise. Might be necessary to produce or to position some barriers to prevent that discharged water from going back into a building possibly, or down the existing drains. You might need to sort of put some mesh screens to stop any contamination going down the drains. And then we're also saying ensure the underground main, rising main and flushing outlet valves are adequately supported so that they are anchored properly when the flushing exercise takes place. We're showing there just one example of what might have to be incorporated to produce the outlet for your flushing exercise. We've shown a separate branch outlet below the control valve set there, discharging out through the outside wall. That's just one example. Each flushing outlet position would be project specific, depends on your circumstances on site. We're also including a table T1 showing you the flows to be run through the pipes at different sizes to ensure that flushing takes place adequately. We're also saying when this flushing should be done and how frequently it should be done. So given that, you know, the contamination that could be inside the underground main would have a detrimental effect on the system to perform, there are certain times when we're saying it really should be carried out immediately. So if you've got obstructions of materials that you've already found in the installation control valve set, for instance, then that definitely shows that you've got some contamination, so you really need to flush at that stage immediately. If you've got any obstructions, materials, debris discharging through the installation during the routine testing, that for sure is showing you that you've got a need for a flush immediately. Any underground mains which have not previously been flushed and where there's no records of previous flushing can show that it's been carried out already. You need to think about flushing those. Underground mains which have been modified or repaired, you certainly need to flush those before those are recommissioned, before the system is recommissioned. And test pressure flow rates at installation control valve sets indicate partial blocking. So if you're doing some tests at the valve set and you're not getting the performance figures that you expect to get, your flow and pressure performance figures, then the chances are that there's some contamination in there, so you might need to flush at that stage. Beyond that, every 5 years, sprinkler installations drawing water from open reservoirs, which are likely to be sort of pushing sort of contamination down the underground main, they should be flushed every 5 years. And then sprinkler installations supplied only with potable water, and every 10 years until the system's been in service for 20 years, and then you should drop the frequency down to 5 years. So that's the frequency of carrying out those flushing operations. And then following the flushing procedure, we're giving some advice as to what you should do. Obviously, if you need to, during the flushing exercise, if you need to close any sectional valves on, say, a ring main to ensure that the flow goes in any one particular direction, or you might have to introduce some blanking plates to ensure the flow goes in any one direction, then you've got to make sure that those are all removed from the system and the valves are open again. Repressurize the underground main using the sprinkler water supplies, and then you'd carry out your normal weekly tests, etc., to make sure that the system is functioning as it should be. And there's just a little commentary and recommendation on the bottom there that we've put together. If you do use blanking plates, obviously you need to make sure that those are out of the system when you finish your flushing, so we're recommending that you actually number all those and log those when you install them so that you can monitor that you've taken them all out when you've completed the flushing exercise. Otherwise, there's a danger you could leave one in the system, and that can have detrimental effects, obviously. So that's the end of the sort of substantial changes. I'm going to hand you back to Dale now, who will just tell you about the future proposals as far as electronic versions of the rules, etc., are concerned. So obviously, if you've got any questions, then we'll try and pick those up at the end of the session.
Yes, thank you, Martin. One thing I will mention is there was an error in the latest TB234 when these were issued back in December. There are some blank pages that were unintentionally left in there, which modified all the headings with regards to the follow-on category of goods that's stored, not category of storage arrangements. Therefore, we hope to be issuing this out to industry and all members by the end of this month, so there'll be a new TB234 coming out to confirm correct the error that was made. Moving on, electronic LPC sprinkler rules. We are hoping to launch soon a PDF online edition. These are in response to growing consumer demand for an electronic version accessible offline. So the CD-ROM we have now removed from sale. So if you have any CD-ROMs currently out there that you are using, they will only have the 2015 Technical Bulletins on them. They will not have any updates. So anybody currently using the CD-ROM, you will not have the latest 2018 Technical Bulletin updates on. So the new PDF will work by locking a PDF device on the first device it's opened on. So if a customer pays for one license, the document can only be opened by the one device that it's first opened up on, or locked to, so to speak, and it cannot be decrypted if forwarded onto other recipients. It will work on all modern platforms, portable devices, browsers, iPhones, etc. You will have the ability to print pages and mark up the document with sticky notes. So it is a user-friendly online PDF version. It will be licensed per device that it is used upon, and it's going to be launched at a special price of £255 per device, which, in comparison to just purchasing the 12845 standard from the BSI, you would have to pay £366 for that, and you do not get any technical bulletins, so we think that's a reasonable price to launch this at. So hopefully by the end of this month, start of next month, I'm reliably told there will be a PDF version. And to finish it off, the LPC rules for sprinkler installations, as you can see there, the reliabilities are in the region of 92 to 98%. At the FPA, we aim to continue to provide a specification which provides first-rate levels of protection at reasonable system costs. We'd like to thank you all as ongoing supporters and contributors and users of this standard. And I thank you to all those that have contributed to the latest TB changes in 2018. Any inquiries that you may have, please contact the details on the screen at the moment. Any technical questions that we can't answer today, please send them through to technical@thefpa.co.uk. And I would like to, on behalf of the FPA, thank you all very much for listening. And we shall now answer a couple of questions that have come in. Is that correct, Martin?
Yeah, sure. There's been a number of questions regarding the new TB237, not surprisingly. So very briefly, because we've not got a lot of time now. There was a question raised about why the flushing requirement has come in now. Has there been anything particular that's happened that suggests it's urgently needed now? The answer to that is not really. It's been on the agenda for a while. Insurance have been particularly keen on it, as in fact have the trade. BAFSA were involved, LPCB, BRE and FIRAS were consulted, so everybody felt it was a necessary requirement. So that's the answer to that one. There's no pivotal event that's meant it's necessary now compared to yesterday, so to speak. There was concerns about the costs, whether clients would be able to do this, whether they'd be keen to do it. I think the answer really to that is, as a standard, if we can see a problem with the debris in an underground main, which clearly there could be, then it's a necessity really. It's not a cost issue, it's a necessity. There was another question here about do you have any confidence that the insurers will require this flushing to be undertaken? Well, it was essentially the insurers who wanted the TB, so I would have expected most insurers to insist on this. Obviously, there'll be a project-by-project sort of consideration, but I would have thought in most cases they would want that flushing to take place. Another question, some water authorities are nervous about water from sprinkler systems being discharged into the water course. So we've kind of covered that one as much as we can in TB237.2.1b. So when you read the whole document, you'll see that we've covered that particular aspect as well as we can. There was another question about the need for this flushing document and whether in fact some of the aspects in the TB are entirely necessary. Well, in terms of NFPA and FM, what TB237 does is it doesn't overstate the need or the means of flushing, so we don't feel that it's necessarily any more than it needs to be. There was a question mark here about whether the Annex D 20mm flushing valve is now necessary or is now going to be affected by this new clause on flushing. Some people are using this N20mm flushing valve to test the flow switch alarm. We've now sort of said in the new flushing TB 229 that should be a 40mm. Well, that end-of-line flushing valve shouldn't be used for testing the flow alarm anyway. You should be using a valve that's replicating one head going off, so it shouldn't be used. So it might be used in practice, but it shouldn't be used technically. So I don't see the change in the end flushing valve issue is a problem there. Commentary and recommendations regarding this air being trapped. There was a question mark about whether the air wouldn't be vented when the sprinkler heads operate on a gridded system. Well, yes, they will do in the operating ranges, but not in the non-operating ranges, as I explained in this webinar. So there's absolutely a need to vent those. So that's some of the questions that we've had so far. I'm just going to check to see whether we've got any more in the last few minutes. We've got some more. We've just had asked if we could get a copy of the slideshow and the presentation. Well, yes, if you are a member of the FPA and RISCAUthority, we will be distributing the links to this webinar, so the material will be available to all members of the FPA and RISCAUthority. And I think that concludes the webinar.
Yes, thank you everyone for listening in today. I do apologise, I haven't been able to get back to everybody who popped in a few technical queries. I've had a few issues with this laptop, unfortunately, but thank you very much. And if anyone does have any questions about the webinars or any future webinars, just email webinars@thespa.co.uk and I'll be happy to help. Thanks very much. We hope you have a lovely rest of your day. Thank you.